Thanks for being here. This talk has to do with minimalism in the Ruby community, which is not something very common, and I wanted to share with you the ideas that motivate the creation of this kind of thing and tell you what is the current status of what the community is doing right now. So this apparently is something typical in Uruguay. These are called Ricarditos. So if you have any questions at the end, the people who ask the question can keep the Ricardito, or you can pick it up and smash it at someone. There are about 7 here. And I also thought of raffling this orange. I said the banana, he said, but it was the orange. So think about questions, and you get this as a prize. I'm Michel Martens. I was born in Peru. I was brought up in Argentina. I'm sovereign in Twitter. I'm the same user in GitHub. So there you can see the projects I do. I'm co-founder of Open Redis, which is a provider of Redis hosting, which is a database that we saw earlier today. And part of the point has to do with the fact that many of the popular tools in Ruby are tools that try to solve a lot of different problems, and as a result of that, they have lots and lots of code, lots of internal complexity and low-quality code. And the idea of minimalism is writing tools focused on solving something specific, and doing this with less complexity and with the best quality possible. And part of the issue came up from the concept of using code to solve problems. This sounds obvious, of course, but the truth is that if we were in the ideal world, we wouldn't have any problems. We wouldn't even have the need of writing code. Now, the paradox of solving problems with code is that as soon as we start writing code, we start adding complexity to the world, complexity that was absent before, and somehow we are changing one problem for another. We are changing an original problem for an artificial problem. And the new problem has to be more manageable and simpler. So if the new problem is more complicated than the original problem, the world is worse. So that is the paradox of software development, and as a result of that, we have to strike a balance between the new problem and the original problem. If we can solve a problem with 10 lines of codes and we're using 10,000 lines, we're creating lots and lots of waste, and the problem is even greater. And to illustrate this, I will speak about a couple of tools that are mentioned last year. Ruby has a couple of defects that prevents you from doing modular programming in a safe way. And one of these problems, and one of the most serious problems, is Ruby Gems, which is the Ruby packet manager. The problem this has is that by default, all dependencies are contained in a global file. So if we had one single project, we wouldn't have any problems because all the dependencies in that directory are all the ones that we need. But as soon as we add another project and we add another set of dependencies to that global directory, we will have conflicts, different versions of the same library. And as from that point, whenever we execute a program, we need to tell our program which specific libraries to load and which not. So there is a solution which is used by the majority of the community, which is a bundler, which is an alternative of brute force. Whenever we're going to execute a program, we determine all the dependency trees and we choose the one that applies. And that, of course, as we add on more and more projects, becomes even work because we have more gems and more dependency trees. So Bundler does a trick, which is estimating that dependency trees whenever we change the dependencies, and then it stores the list of the gems with its own versions. And this is what I call in this slide version tracking of the specific dependencies. Now we have a minor problem. We want to eliminate a project forever. We don't know which gems we can eliminate.
of that global directory. So it's bad in the two senses. But speaking of tracking the versions and isolating the dependencies in the project to solve the problem, one of the tools that I wanted to show is deb. What it does is just to keep record of the gems and the versions that we're going to use. That's the only thing it does. So it doesn't solve the problems that Bundler solves, but at least it gives us information as to whether the tools or the dependencies of a project are installed or not. And another tool is GS. What it gives us, what it does is it isolates the gems per project. So you enter a global directory with all the dependency, and we have one directory per each project. The gems are going to have the same life cycle as the project that we are using them for. And it has several things in favor. For instance, the startup or booting a project will be much faster because you don't have to calculate thousands of books of directory, nor do you have to go to a directory with thousands of gems and activate them also, but you activate only those of that project. And as it has the same life cycle of a project, the gems will leave when we discontinue a project. And when you break down these two parts, we can also replace each of them. For instance, I use deb with GS, but we have another alternative that is GST. That's a tool written in Bash, and it plays the same role, but in a different manner. There's another one that was produced lately that is BS, that sort of generalizes the problem, and it solves it in a way that's very elegant. It's also in Bash, and it can be used for similar problems managing the surrounding, the environment issues. And the thing is that if here we had just one tool to solve everything, we should have added different features and create a larger tool, and that would make our life more difficult. So that may also be interesting for the startups. So if we compare one solution and the other, one is brutal force, and the other one is doing a trade-off with space in the disk, because it may take more space in the disk, but we have an advantage because we don't have to calculate anything when we execute a project, and it can solve the problem in a much more elegant manner. What I want to show here is the difference between the code lines. We always speak of the lines of code, or at least in my case, I speak a lot about the lines of code. And here it's more or less clear that there's a very strong correlation between the lines of code and the complexity. You see that it's almost a linear relationship. And graphically, you see that you have a deb.gs that is 55 times smaller than Bundler and 71 times less complex. So maybe you are using a tool that is not the most adequate. We are not attacking the problem. We are not tackling the problem from the best angle. This is a phrase that I discovered recently. It was written by Einstein in 1905. If a body gives off the energy I in the form of radiation energy, it's a mass diminished by L over V. And then he rewrote it, and only 44 years later he refined it, and this is the version that we all know and that we all remember. So here I like to show how the idea was tuned up. Maybe it's the same way to express the same thing, but you finally get to the most elegant way of saying it. This is another example. I don't know whether you are familiar with the chess notation. In 1614, they kept a record of each move. The white king commands his own knight into the third house before his own bishop. So they didn't record all, but then they described just the first four movements, and after that they said, and then the white king won the battle and this and that. And finally, the idea is to present more information, and then 100 years later they compressed the versions, and then in the mid-20th century, and now this is the concise way of saying it. To put the coordinates for a chess professional, they need to write down each move, and that created databases with the games of all the players. The information is shared. The theory of chess is compared. The style of the different players is also compared, and the computers used this to feed the databases. And in the meantime, in the Ruby world, or at least when I started programming with Ruby, this was the way this was tested, very direct. So we put what we wanted to compare, but in 2005 with Aspect we could already write a little bit more for exactly the same, and it had improvements that enabled us to write more and more until finally we got to where we are today. When I see this, it's like trying to put poetry where you shouldn't, and it's going backwards in history. And we are also sacrificing things that we shouldn't sacrifice. For instance, the author of Cucumber says, well, this is not everything, you need the test. This is less than half, and the author recommends not to test everything with a tool. He says it's too cumbersome to create the test and it's too slow to run it. So we are sacrificing what we should really aim at. So I wanted to show you other tools, but basically we have to remember this of the original problem and the artificial problem. That clearly is an artificial problem that we are creating that doesn't solve what we wanted to do, that was actually to test. This is an example of many other potentials. That is the forking test, this Q test. This is very quick, and each set of tests is loaded in a forked process, so you don't preserve the status of between the different test sets. And really it's very simple to create a library like this. It takes 20 minutes. It's not too complex. And there are many tools that can be changed with these, but the idea is really to focus on the properties of this. This is a simple example. You can see all the documents to see what other things can be done. But again, I repeat, if we compare the original problem and the solution, in this case, we see that the correlation between the lines of code and the complexity continues to exist. Q-test is 60 times smaller than RSpec. And I didn't want to put all the crosses because I didn't have enough room, and it's 51 less complex RSpec than Q-test. There are many simple tools that we can use. This is just one of many examples, but the good thing about it when you handle simple tools is that you can replace the pieces. So there's no need for you to save this or to try to repeat this because this is good for me, but each of you may have different needs depending on the software that you want to solve. And this set of tools, if I put together all the lines of code of all these tools, they are about 1,500, a little bit less than that. So all my stack has less code than Sinatra. That is something that we consider to be a small library. And I also wanted to show you what can be achieved with something like that. This is a site that is Educabilium. That's a market to take courses on and offline. It was not created by me, but by Damian, the creator of Q-test, who's there. It's a work site it's a large work site. Considering the area that it wants to cover, it operates in 9 countries, in 2 languages. It has many, many users, and they have just one server. And with that, they solve everything. Given the scale of the project, you would think that it has more things. But in using tools as the ones I showed you. Another example it's a little bit old-fashioned, but it's a site of the Redis documentation that we created with Damian. It's a site that is about 4 years old, and it has updates about contents, but not programming. If there's a vulnerability, we have to run and fix it. So it's there. We're just discussing that we should change the typography, but 4 years without having to devote a minute to this. This should be something that we should all aim at. Another example is OpenRedis, the company where I work. This is just to use to show that I don't use Rails and come to recommend something else. Another example is a website to offer jobs. It was created by a team that this was the first project of the people. They started from scratch. Each gem that they added, they led the code. Each line they added, they knew what the purpose was. And after 3 months, they had the project almost completed. They had just problem of some design, so they opened a company in Delaware so that for payment issues. And initially they had the site in Heroku, and then they decided to install it in Amazon. They learned to set up. They did this in just 2 months to people who didn't know about Ruby, who had never done anything like this. So this is good to show that you don't need to be a guru or a Ruby expert to go from Rails to using tools like this. And it's also good for beginners because it gives them absolute control of what they are doing. And also, sort of stemming from this, they are also now aware about the complexity, that it might not be so usual among people that are just starting. So, if we have many simple tools that solve the same problems that don't use so many resources, why is it that most people continue to use such complex tools? I think a lot has to do with a sort of mythology that was created around some tools. I think that Foka mentioned this at the beginning. We'll see why later.
So these are myths that repeat again and again, and I listen to them again and again, and these are barriers that you have to pull down. One of these is the concept that if you take tools separately, you need some sort of glue to bring all those together and make them work. And that is a false concept. I don't know where that originated, but if these are well-designed tools and have a specific role and have a clear interface, it is not necessary to add code so that they work together. Another case is the concept of when you use simple tools, you end up rewriting Rails or rewriting half of Rails. That is always being said. There's a discussion for and say, well, those simple tools end up having the same end complexity. That's an absolute lie. And in fact, what I started to think about when I was thinking about this, if you choose simple tools, then your application should also be simple, not the opposite. It is not someone that racks their brains to write 150,000 lines of code in the application. I say 150,000 because that is what Rails measures. The truth is that Rails has lots of things that you don't really need. The things that nobody needs even. Things that nobody ever used, but they are there. And once again, the idea is to trying to determine what we want to solve. Sometimes we want to solve something that is very specific. We have tools that we need. Rails makes lots and lots of promises, but sometimes it's not the adequate solution. There's another myth, is this, that Foka was referring to, how updated is a library. Foka was telling us about the fact that when you use ls to see the contents of a file, you look at the directory. You don't ask yourself who was the creator. You didn't ask yourself who was the creator or when it was updated, or there's a DLS conference, but it's small and it works. And some time ago, Cecilia told us of a discussion at a forum of a guy who was saying this. Well, at my company, we hired a team to do a prototype and using Cuba. And this hasn't been updated for 6 months. I don't know what I'm going to do, because then I will have the project and I don't know what will happen. So everything went and said, well, tell them to use Rails, ask them to change. And others thought more and said, well, no. Of course, let them use Rails or use Sinatra or even Padrino, but Cuba, I never heard about Cuba. So 2 weeks later, the same guy made another comment. Well, to tell the truth, I gave you the opportunity. I saw how you work. I like what you're doing. I read the Cuba code. It's 143 lines. And I realized that if nobody's going to maintain it ever, it's not a problem. I understand. I like the way it works. I like the tools you chose. I'm happy. I'm glad I gave you the opportunity. But of course, more comments came in of people who said, no, that's a very serious mistake and things of the kind. And the latest comment, which is brilliant, came from a guy who said, well, if you didn't choose Rails, don't pay them, because only you should have made that decision, and it is irresponsible on your behalf. And by that time, people don't even know what Cuba is. Nobody even asked what the original problem had been. So it's like discussing, well, use a screwdriver, don't use a hammer. So, well, doesn't matter. Okay, I started getting passionate about this. No, we have the capacity of discussing things from the technical point of view, and we continue discussing this from our emotional side. Now, speaking about our emotional side, I was guilty some time ago and said, well, Rails is just totally useless. Sorry, that was the conclusion I arrived at that time. But I had reached that conclusion without any arguments. So you can say Rails is worthless, and then you become defensive, and that's the end of the argument. And although I had my reasons for saying, well, it's not a good way to start a technical discussion. Now, today, it still happens, and someone says that today is dead, or such and such a design pattern is the best, and this other one that used to be the best is no longer great. And today have lots of metrics to measure the complexity and code lines, like what we saw just now. I didn't say this earlier, but the tool I used is Flow. And this is used to measure the complexity and the amount of assignments and branches and the calls to the method that you have. So this is very useful for discussions such as these. Additionally, we have heuristics as ways of style to see if a code is legible or not. Because I can say I do Rails in one line of code and I put colon, but if you measure the complexity, it's very, very big. So this is what I'm concerned about, the idea of taking this discussion to the technical level and taking out the emotional component. Now, why do we use tools that are so difficult or so complex? The Rubik community has a pathway to fame that has to do with creating tools that solve many, many problems at the same time. Maybe someone creates a tool that solves one problem, and that tool will have that author as a user, maybe a couple more that came across that problem. And when a new problem comes up, the author can either create a new problem to solve this other problem or to add a couple of lines of code to cover this new other case. And Ruby is a language of such a high level that it makes this easier. So you can add a couple of lines and then you cover the new case of use. So that duplicates the number of users of your library. And if you follow that, you keep on adding new user cases and you have more and more users and it becomes difficult to maintain. So you add on collaborators. So you'll have a fragile product, but that is very popular. And something that is inherent to our communities is this of using popularity as a criterion when you choose a library. So if you have two tools that solve the same problem, the one that is more popular is chosen. And it doesn't matter how many lines of code. So once it has become popular, it's like a vicious circular, and it's something you cannot stop. So that's what I call the popularity trap. So the basis of all this is that we are discussing something that is a defect. We're considering this a virtue. So that can be a serious defect of the design. And I think that anyone who studies modular programming knows it's that way, but there's an emotional component that prevents us from seeing this. That is why we have these myths that endure time. And what I have just said is a practical part of minimalism. So we spoke about performance and simplicity and having to dedicate less time to this. But then there is another dimension that was also referred to today, which is a moral dimension. This is something that we should stop to think about as programmers. I don't know if the moral dimension is the adequate term, but let me tell you about Christopher Alexander. He is an architect who's about 80 years old or so, and he wrote a book called A Pattern Language, among other books he wrote. And this book had a strong influence on the world of programming, because what we see today and everything we discuss 40 years later came from this book.
It's a book. It's very deep. And as he's an architect, he speaks of construction, of building. He speaks of how to build in the world, to draw the best of each human being, how to build to make people more creative, more or happier, so that they can share time with other people. Each pattern has a name, a description of the problem, the research conducted by the author and his team on that problem, and the proposal. So, for instance, you have patterns that range from how to put a window, the size of each room, and how a neighborhood should be, or how the buses should be, and the global government of the world, but very much in-depth analysis, and always thinking of creativity and well-being. For instance, when he speaks of distributed working places, so he says that when you polarize the places where people work in a city, children don't see adults. And the idea is that parents, for instance, should be able to have lunch with their children. That has nothing to do with architecture, not what you're taught at school, but it's like a new dimension that this person created. And we, in the software world, we have this issue of the patterns, but we only have it as language, to speak of ideas or to known solutions or to usual problems. The book, the original book, has three dimensions. One is this language, another is the moral dimension that I just mentioned, and another one is the ability, the capacity to generate things, because each pattern is related to larger and smaller patterns. So if you want to use any of these patterns, you know what to connect it with in such a way that you may get something consistent as a result. In software, we don't have that, nor do we have a moral dimension. And there's a talk. Well, his book was a boom in Silicon Valley. He was invited to give a talk the talk was 20 years after he had written the book. He was a guru by then. And so he conducted this research about this world. He didn't know about this. And in his talk, he said, "It seems strange for me that you chose what was less valuable of my book. You have words that you can use to call common solutions to common problems, but nowhere do I see this issue of making the most of people, of having people give their best." By then, 20 years had gone by after the book had been published. He was absolutely frustrated with the world of architecture because he thought that he was going to change the world. But architects build 5% of everything actually in the world. And each builds what they can, and there are cities that are collapsing. Buenos Aires, for instance, is impossible. And at the time, this was 1996, and he was hopeful that he would be able to change the people's mind so that people would look for the moral dimension and this more creative solution. And actually 20 years have gone by, and this is something that we don't have yet. What is the moral dimension of what we do? I have no idea. At the time, he said that it was sort of as if we were murderers paid to have sites. For instance, if you click on a banner just by mistake, then you do that. This is something that he didn't do, as if we were guns for hire. So when you just think of the morale, you can think of open source, for instance, that it's very good, but maybe it's not enough. It's not the whole thing. When they said that Firefox would have DRM as all the other routers, I realized that regardless that it's a foundation and that's open source, we are limited to very few options of browsers. And even if we wanted to create a browser and they give us a week, we can't do it because it's so complex that we limit it to ourselves. So there may be a new dimension that has to do with simplicity. It may be that, for instance, we may consider the environmental impact of what we do. It's an open question. I'm just saying this as an example. But for instance, the fact that Mozilla needs 1,000 servers of continuous just to see programs on the internet, it's ridiculous if we think of it. It's ridiculous that we are unable to write them ourselves, and all because we create these platforms that enable us to see text, to see images and video, to connect with another browser just because. And if we had developed separate tools, each of them could have their RTC web implementation. So I think that that's something that is food for thought. Now, in our case, there's something that writing codes is very easy. Solving problems with more codes, it's easier. There's another myth that I'd like to tear down, is that if there are enough eyes, there are no difficult bugs. Everything can be fixed. But there's evidence everywhere telling us that that's not the case. I don't want to mention rates again, but there are 5, 6 issues, security issues. So complexity doesn't come for free. And we should look for the way we can solve the problem with less instead of adding, and have our heroes that contribute with more and more codes. In Rails, there are 5,000 commits between one version and the other. It's more than I ever committed in my life. And this leads me to think, well, as Mozilla has 2,000 servers, the same thing happens to us. We are running a test, it takes a minute, and then we go on, and after 1 month, 5 minutes, and 2 months, 10 minutes, and then we hire a server. And for mankind, we're going worse and worse, even if we solve the problem. So another thing that happens is that if you look for a job in Ruby now. They're all jobs, all in Rails, and it's to inherit a project that was abandoned. So somebody abandoned a project and you inherit it. And in all the cases, we are speaking of artificial problems. We are not solving the original problem. We are looking for someone that can struggle with this Rails or whatever project. So you could think that there's not such a demand of programmers, but maybe we have more than enough and we're doing things wrong. If there are tools such as Arthur, for instance, that a person needs to devote 10 years of his life to solve something that just one person in 140 years of code could have fixed. Maybe it's a waste of time. There's some hope, because I see that lately there's been a change in the feelings in the community, at least in South America and Argentina and Uruguay. We see that there is sort of a new wave of this line of thought, and everything that I saw these days for me was wonderful. Maybe under the influence of the organizers, that are people that share this mentality. And there's an initiative that is MicroRB, that's a website, and it's sort of a selection of simple tools as the tools recommended. It's not my initiative. It's a group of people. Maybe it's not the alternative that I would propose. I don't really like the idea of having a list, because I think it's very difficult to draw a line saying what to recommend and what not to. But anyway, as it's open and it's an RC channel, then we can say things. Well, I have a Ricardito if someone helps me with this. Another initiative, this is the good one. This was created by people of our community. It's Less Code. It's an initiative that doesn't have to do with Ruby specifically, but many of us are between Ruby and other languages. There are people here that read ideas in JavaScript and Lua. And the interesting thing is that these ideas may be debated regardless the language you use.
And here there's no selection or recommendation in terms of code, but yes, in terms of ideas. The idea is to approach all these issues from the technical point of view, and you can enter the channel and ask for advice or discuss things, because we love all this. We love to discuss all these issues. So if you thought that any of what I have said is interesting, or what you have seen during the conference inspires you to follow this way, I invite you. You're more than welcome. And this has the big defect that it is very slow to disseminate through conferences, because we don't have that many conferences. You have the one in Uruguay, the one in Argentina, so we won't end up changing the world overnight. And so not even Alexander managed to do this. It's not a lost battle, but the more we are, the more chances we'll have of interacting, the more free time we will have, less time to dedicate to writing code. So that is all. Thank you very much.